What if your AI assistant only knew what you told it to do it so? No hallucination, no made up facts, just your documents. That's exactly what I built it this week. Hi, I am Aarti, and today I will be demonstrating an extended version of my document retrieval system project. Here I have implemented RAG pipeline, which is also known as Retrieval-Augmented Generation, and I'm running it completely local on my device with zero API cost. Let me show you how. So let's have a look at my VS Code base. I have a file named rag.py. It's a Python file which consists of a class called RAG system, and it's implementing all the RAG pipeline over here. I've also got like default system prompt, which would be always present in my interface whenever we're trying to perform a search. I have another file called LLM.py, which is actually implementing the LLM client. For LLM, I'm using Ollama, and it has got a class called LLM client, which is implementing all the logics related to this and all the LLM endpoints. I have also I have a test files now for both of these files. First is the test.llmpy and RAG. In addition to this, I have introduced a new HTML file where we're going to have a look of our interface, which is kind of similar to OpenAI. And the logic related to this is mentioned over here. I'll be running my Pytest right now because it always takes a lot of time to run. So using UV run Pytest, we'll have a look at code coverage. And by the time our Pytest is running, we're going to have a look at our interface. So for this, I've already started my server and all my documents have already been loaded here. And let's have a look at our interface. So this is my playground.html where I will be showing you how it works. So let me run a query over here. So I've already got these parameters, which is like context documents to show. It's like 3 right now. We have a temperature already set to 7. These all are adjustable. The default prompt that I showed you in my VS Code is what is generated over here. And you can type your own system prompt if you want to look into how it looks like, so you can have a full prompt preview. Now let's try running a query over here, which could be like, and see what it generates. While it is thinking, it is going through a RAG pipeline at the backend. So first step is that it retrieves the most relevant chunk from the Dracula text document. Next, it would build a context, a string from it. The third step is that it would craft a prompt which would contain the context string along with my question. And finally, we have like a Ollama, which would generate an answer locally. No data is living out of my machine now. And there it is. So notice the blue highlighted. These are the citation from where the chunks are being drawn out. We can click it to check like what content it has. Sample all the 3 files we can see over here. The whole point of RAG is not making things up. It is grounded in your data. So you can also see that there is this metadata over here, which says the time which it took to generate this, documents which are being displayed, number of words, and the temperature, which is also we can adjust from here. So now let's have a look at our health of our website, how to check the health of our website. So we have our localhost already running, and I'll just type a health, hit enter. So now you can see there's a JSON file. Looking at this, our status is healthy, documents are indexed. So we have total 657 of these. You can see that there is a tag that I have mentioned here, which says RAG available true. It says that, okay, I have my RAG running behind. This means my local Ollama LLM is actually running and it is ready to go. This field didn't exist in my previous lab work. I added specifically to tell the system that whether my AI is well connected or not. Now I can show you my GitHub as well, my workflow. Here I'm running a CI/CD workflow as well, and you can see all checks have been passed over here. So one thing is that my CI pipeline runs on every single push. And the problem with the LLM is that you can't call a real AI automated in tests. So that would make it very slow and expensive and even non-deterministic. So let's get back to our VS Code again and check how far our code coverage has been done. So this is still being running right now. So we kind of need to wait for some more time. What I actually learned from RAG. RAG might sound complicated, but the pattern is actually very simple. It's just retrieve, augment, and then generate. These 3 steps. And the magic lies in the details, like how you chunk the documents, how you write your system prompt, how you handle the cases where there is just not enough text. So the hardest part would be for me is the timeout issues. My first queries, they were timing out at like 30 seconds because my model was like cold loading. And the fix was like I increased the timeout to 120 seconds. And it kind of taught me that LLMs are actually a slow infrastructure. You need to engineer around that. And the thing that surprised me the most was like how much the system prompt matters. Same question that can be answered differently. And that's prompt engineering. And now I also have like a playground.html to experiment with it. So we have our test code coverage ready. We've got like 87%, and 97 of the test cases have been passed. That is all. And it kind of took a really long time to finish all this code coverage, which was like 22 minutes. It's a really long time. So this is the foundation of basically every production AI that you have ever seen. We can have a look at the rough check now. So it will be UV run rough check, and wait, all checks have been passed. Similarly, we can have a look at the format. Okay, so the GitHub link is mentioned in the description box. Thank you for watching.